All right, here we have a problem where a girl is riding a bicycle at a constant velocity of 3.5 meter per second. At time t is equals to 0, she passes a boy B sitting on a bicycle that is stationary, as you can see in the figure. Now, at time t0, the boy set off to catch up with the girl. He accelerates uniformly from time t is equals to 0 until he reaches a speed of 5.6 meter per second in a time of 5.0 seconds. He then continues at a constant speed of 5.6 meters per second. At time t is equals to t, the boy catches up with the girl. T is measured in seconds. State in terms of t the distance moved by the girl before the boy catches up with her. For this question, it's quite maybe overwhelming, but it's actually very simple. So we all know the basic equation for speed is equals to distance over time, right? So that's speed is equals to distance over time. Since we're trying to solve for distance, then we can just simply use distance equals to speed multiplied by time. Question is, what is the speed and what would be the time? We all know the time is already equal to t, right? And we know that the girl is actually moving in a constant speed, which is what? 3.5, right? 3.5. Therefore, the value now here would be 3.5 t. Okay? Remember, you want to know just what's the distance traveled by the girl when the boy catches up with her. Since the time given when the boy catches up the girl is at capital T, and the girl is just simply moving at a constant velocity of 3.5, then it's just correct to say that 3.5 t would be now the distance. You can solve for the t eventually, but that's not the questions given here. They even mention state in terms of t, what would be the distance. So the correct answer, 3.5 t. Now, for the next question, you are asked to find out what is the distance moved during the boy's acceleration. In order for us to solve this, you'll be using two equations. The first one is the acceleration one, Vf minus Vi over time. Or if you want, you can also express it in V minus U. Okay, easier ways. And then of course, afterwards, you'll be using this one. S is equals to ut plus 1 half at squared. Okay, let's solve for the acceleration first. So given this, your initial acceleration is 0, final is 5.6, so that's 5.6 minus 0 over 5. Let's see what we'll get. 5.6 divided by 5, you'll get 1.12. 1.12 meter per second squared. Then from here, solve for the distance. Um, since the boy started at rest, right, most likely this will become 0. So now your equation is going to be just 1 half at squared. So that's 1 half 1.12 multiplied by 5 squared. What would be the value? 14 meters. Okay, this is how you solve your uh, kinematics equation.